All right, hello everybody, and welcome to the almost weekly live coding stream. I posted on Discord a query about what people might want to see, and we got a suggestion that we should look at dragging of sprites and snapping of sprites together, like you might use in a construction game or in an inventory system. We actually have such a system in our game Descent into Darkness. Actually, maybe I'll fire that up real quick and demonstrate. But then we'll come back to an empty folder and we'll start from scratch and see how it's done. But real quick, let's go into Descent into Darkness, mount the user folder, and I'll just reboot. Okay, and here's our inventory system, and you can see each of these little items are sprites, and when I mouse over them, they grow slightly. And if I grab one and drag it around, I can place it very sloppily where it belongs, and it'll snap into place. Can't wear boots on your head, so there's a little bit of validation too. You can carry boots in your hand or wear them on your feet. Or if I put it on this grid over here, anywhere I drop it, it will slide into the closest place. Again, if I'm too sloppy about it, it will just pop down to here. This is sort of the drop area. But anyways, the point is, here's an example of sprite dragging and snapping. Oops, you can't wear an apple on your finger like a ring, but you can hold it in your hand. Anyway, that's that. So, how does this work? Well, let's go to a new, almost empty folder. This is my daily purge folder. Ask me on Discord sometime about my daily purge folder. I'm unreasonably proud of that too. But it has nothing to do with Miniscript or Minimicro really. Oops. Okay. And actually, I'm going to just reboot. Make sure everything is completely reset and cleared. So I have prepared one thing ahead of time for today's project, and that is this picture of chinchillas. If I view chinchillas.jpg, this is the picture we're going to be working with. And I thought a fun way to play around with sprite dragging and snapping would be to make sort of a jigsaw puzzle out of this. We'll cut it into like 6x4 pieces, little squares, that you can drag around and snap together to reassemble a picture. So that's going to be our goal. So let's edit and jump right in. Let's see, the first thing we need to do is load the background, or load the source image and cut it into a bunch of little sprites. Okay, so let's see, image equals file.load image chinchillas. Oops. And then, let's see, I earlier worked out that this 612 by 408 image, both of those numbers are divisible by 102, right? And 408 is going to be divisible 4 times. So we're going to make our little sub-images 102 by 102. Or another way to think of it is we're just going to cut it into 6 by 4 smaller blocks. So let's see, for column in range, that's column in range 0 to 5, and for row in range 0 to 3. We want to get a subsection of the image, and we want to make it a sprite. So we'll do something like sp for sprite equals new sprite, sp.image equals img.getImage, column times 102, row times 102, the width and height are also 102, and then we want to add it to our display. I should probably do a clear before everything else. And when you clear, display 4 gets set up as a sprite display. So we're going to use display4.sprites.push sp, and that should do that. Okay, and so here they all are hanging out down in the corner. Let's do a little bit more. Let's assign each one a random initial position. So sp.x equals round of 960 times R&D. sp.y equals round of 640 times R&D. Oops. I reflexively hit save. You might have seen that save dialog pop up. And then I actually hit close, also reflexively. We'll call this puzzle and save it there. Okay. Yeah. So here are two little chinchillas, all carved up, not looking nearly so cute in pieces. And now we want to be able to grab any of these and drag it around and not just do a text selection on the text display. So how do we do that? Well, the first thing we need to do is figure out which pieces hit. And for the sake of debugging, it would be sure convenient if every sprite had a name that we could print out. So I'm going to give every sprite a name. I'll just do sp.name equals, let's say column plus a comma and a row. And let's see, we'll say piece, column, row. So it'll be piece 0, 0, piece 0, 1, and so forth, all the way up to piece 5, 3. So now I can do something like, for the sake of testing, I want to make it so that when I mouse over a piece, the name of the piece is printed on the screen somewhere. And for that, we need what? We need a function that tells us what piece is under the mouse. So I'll call it piece under mouse, this function. You know what? I'll go ahead and say sprite under mouse. Okay. And what we need to do is use the contains method on a sprite to just check each one. And we're going to check them in reverse order so that if there are two sprites overlapping, the one that's on top is the one that gets returned first. So we'll say for I in range display for.sprites.length -1. So if there's 24 sprites, the length will be 24. This will be range 23, which goes from 23 down to 0. And this is safe as long as we know that there is at least one sprite. If there were no sprites, we should probably check for that. I'm going to get tired of typing display for sprites all the time, so I'm going to just shorten it by assigning to a local variable. And then we can say if not sprites, then return null. Okay, so for now, I in range sprites.length -1. The sprites I contains mouse, then return sprites I. And for and function. Okay, so now we can put in a main loop for the sake of testing. While true. sp equals sprite under mouse. If sp then, I want to move the cursor someplace. Text.row equals 25. Text.column equals 0. Print sp.name. Else print just a bunch of spaces to wipe out any previously printed name, and do that forever, maybe with a yield, so that we only do it 60 times per second. Too many arguments on line 21. All right, debugging time. If sprites I contains mouse, then return. Yeah, okay. Sprites isn't a function, it's a list. So square brackets to index into something. Okay. Right, and it's not working because we never set up bounding boxes on these sprites. So let's go back up to here where we're defining the sprites. Let's do sp.localBounds equals new bounds. And then we have to give it the right size. So sp.local bounds.width equals sp.image.width. And we'll do the same for the height. This is kind of boilerplate. And let me show you a reference. Let's go to the how-to articles on the wiki. There should be how to detect clicks on a sprite. Yep, how to detect a click on a sprite. Okay, and this is what we're doing here. You set the local bounds to a new bounds object. You set the width and height equal to the image width and height. And assuming that your image goes, you want to be able to click anywhere in the image area, this works fine. If your image has a lot of empty space around the edges that you don't want to be clickable, then you would, set the width and height to something smaller. But for the typical case, this is all you have to do. Once you set this local bounds object up, then the contains method will automatically do the right thing. So let's try it. Okay, cool. So here's piece 2.1, piece 5.3, piece 4.1, and so on. I still can't click and drag them, but at least I can tell which piece the mouse is over. And let's check where they overlap. Here I'm on piece 0.0. Here I'm on piece 0.1, and where they overlap, I'm getting piece 0.1 because that's drawn on top, which is exactly what I would want. So that's working well. So far, so good. Oh, I have some new unreads on the Discord. No, I don't. Discord lied to me. Okay. So, clicking and dragging. The basic idea on clicking and dragging is when the mouse goes down, you note what it is that is being grabbed by the mouse. In other words, which sprite is under the mouse at the time. And then as long as the mouse is down, however the mouse moves, you want to move that sprite or sprites in the same way. There's really two ways to think of it. You could either keep track of the last mouse position and the new mouse position and figure if the mouse moved 5 pixels, then I need to move all the sprites 5 pixels. Or you can look at it as, if this is my sprite and I clicked here, let's say a certain offset from the center of the sprite, then wherever the mouse moves, I need to put the sprite that same relative offset to the mouse position. Both methods will work, which is going to be easier in this case. I'm trying to think ahead to when we're going to be dragging multiple pieces that have been snapped together. It doesn't really matter unless you're going to limit the sprites. If we wanted to limit the sprites to, say, the visible area of the screen so that you can't drag them off screen and lose them, then it's better to keep the offset relative to the mouse. Otherwise, as soon as you move the mouse off screen, you stop moving the sprite, and then when you move the mouse back, the sprite is now no longer under the mouse. So we're going to do it where we note the relative position of the piece compared to the mouse, and then we just drag it. We keep that relative position as the mouse moves. So let's not do this text business anymore. Instead, what we really need to pay attention to is whether the mouse button is down. So if mouse.button, then we check if there's a sprite under the mouse. And if there is, then we want to drag. We'll just do this all in the main loop for now. I may refactor it later to keep it neat, but let's see. We need some global variables to help us. Let's see. Drag item. That's going to be the sprite that is currently being dragged. And that's initially null. And then drag offset equals 0, 0. This is relative. Why can't I spell relative X and Y offset of drag item to mouse. Okay, so let's make a pickup method. And it takes a Sprite SP, and it's going to just do globals dot drag item equals SP, globals dot drag offset equals mouse dot x. Let's do it the other way. Let's do sprite dot x minus mouse dot x and sprite dot y minus mouse dot y. Okay. Continue drag this function. I know I said I was going to do it all in the main loop, but these helper methods are simple enough and seem worth doing. Well, whenever we continue the drag, we just need to do drag item.x equals mouse.x plus drag offset 0 and drag item.y equals mouse.y plus drag offset 1. Okay, so if the mouse button goes down and there's a sprite under the mouse, then we're going to do pickup sprite. And then while mouse.button is still down, we're going to do continue drag and yield, and then end drag, which is another function I should define. End drag is just going to do globals.drag item equals null, globals.drag offset. I wouldn't really need to reset that, but why not? And I realized if we have continue drag and end drag, this function really should be called start drag or begin drag. So we're going to go with that. Okay. And all of this is supposed to be true only while, or only if the mouse button went down. Otherwise, we just keep looping. Let's try it. All right, look at that. We're dragging. So the way this works is when I put the mouse button down, let's say I put it right on this little fella's eye, right in the center of his eye. There's a certain offset between the mouse and the sprite position itself that gets stored in that global drag offset. And then whenever I move the mouse, it updates to that. Now I haven't yet put in any limits, so I could drag this piece off the screen and drop it, and now I have no way to get it back because I can't click outside the screen. Or if I do, it's going to just disable the window. So let's go ahead and do that as well. That would be in continue drag. And actually there's a function in mathutils that's helpful here. Import mathutil called clamp. And the way clamp works is you give it a value and then a minimum and a maximum, and it'll return either the value itself or the min and max if the value is out of range. So we can do mathutil.clamp. This mouse x plus drag offset, same as before, but we'll limit it to 0 to 960. Mathutil.clamp 0 to 640. And now if I try to drag one of these off, it will go no further than that. And as I bring the mouse back in, it smoothly picks up the mouse again. So hooray, we have dragging. Okay, but dragging's the easy bit. I was asked about how to make sprites snap, either snap to a grid or snap to each other. In this case, we're going to do snapping to each other. Snapping to a grid is really no different. It's just a matter of finding, of all the places that the sprite could be if it was snapped into place, which one is the closest, and then you just move the sprite there. And this would be something we do on end drag. So in our case, it's a little complicated because we need to compare the piece to every other piece And we have to figure out what the possible snap positions are. So I'm thinking, give me a second here. I think I want every piece to know what snap points it has. And initially they're going to have snap points for them, one on each side. But if we've already snapped two pieces together, then on that side where there's already a piece, that's not a valid snap point anymore. And so the piece is going to have to keep track of that. All of this makes me think we need to define a Sprite subclass to represent our puzzle pieces. Piece equals new Sprite. Piece.snapPoints equals, and I think I'm going to keep these as XY pairs relative to the position of the sprite. So, and we know that our pieces are 102, so it's going to be minus 102 in the X direction, or minus 102 in the Y direction, or I could splurge on some spaces here, or positive 102 in X, or positive 102 in Y. Okay. And then we have a list of these. Oh, we don't. Well, we have to be careful. The piece class has a list of these. Each individual piece is going to just inherit that list. So when we modify this list, we'll have to be careful to get our own copy, and then take out the one that we're using. But we can do that. So now here, instead of new sprite, we'll just say new piece. I think I want to add some debug drawing. I think that's going to help visualize what's going on. I have a lot of it in my head, but you might not have it all in your head. And even when it's in your head, seeing what the computer's actually doing is really helpful when something goes wrong. So let's add a piece, that debug draw method. And we'll draw in, let's see, sprites are in layer 4, graphics is layer 5 normally. That's not helpful. I'm going to make display 2 display mode pixel, and then we'll debug draw in display 2. So the first thing I want to do is just draw a line out to each of our snap points. So for SP for snap point, I know, here I thought SP was sprite. All right, PT for point. In self.snapPoints, g.line from self.x, self.y to self.x plus 0.0 and self.y plus 0.1, because these are xy pairs. G.color equals color.green. And maybe we'll even draw a little circle at each of those as well. G.fill ellipse. We need these -2, width of 5, height of 5. Okay. And then when are we going to do that? Let's see. Let's update debug display equals function display2.clear, color.clear, display2, nope. For sprite in display4.sprites, sp.debug draw. Is that what I called it? Debug draw, yep. Okay. And for and function. Okay. We'll do that once at the top before the main loop. Update debug display. And then we'll do it whenever we're dragging as well. Let's try that. Keyword end for on line 13. I did something wrong. Oh, I just put a comma here where I didn't need a comma. That was done. Clear not found in map 65. Display2.mode equals display mode pixel. Display2.clear. That should work. Display2 mode equals display mode pixel. It's full of black, as you would expect. But I'm typing blind here, display2.clear, color.clear. That worked. Why didn't it work in our program? Clear not found in map line 65. Which was called from line 71. Update debug display, function display2.clear, color.clear. How could we get down there without having... Oh. No, yeah, we would have had to execute this first. Well, I guess we can go ahead and move this down to make it a little bit harder to understand how this would not work. Hey, there we go. All right. So now you can see each of these pieces has 4 snap points. And those are the points where if you were to put the sender of another sprite right there, those 2 pieces would be perfectly snapped together. And that's what we want to happen next. So I think that's something a piece should be able to do. We're going to ask each of the other pieces on the board if this piece that we're dragging can snap. And if so, how close is it? And then we'll take the one that gives us the best answer, which is the smallest distance to snap, and we'll snap to it. So piece dot get snap dist equals function. I don't like that it's just returning a distance. Well, maybe it's okay. All right, so we're going to check each of our points for pt and self.snap points, like before. Get the x and y of the actual snap point, and then return mathUtil.distance of, let's see, some xy to the new xy. I'm just going to call this other. It's going to be a piece. Right, but we can't just return the distance. We're looping. We're supposed to be returning the best distance. So best dist equals, and we want to have some maximum limit. Let's say 20 pixels. So dist equals this mathUtil distance, and then if dist is less than best dist, then best dist equals dist. If best dist is still equal to 20, then return null, otherwise return best dist. So given another piece, this is going to examine each of its snap points and return either a distance less than 20 or null. And then piece.snap is function other. It's going to look awfully similar, but its purpose is different. Instead of just returning the distance, it's supposed to actually actually do the snap. So best idx equals null. And here we're going to do for I and self.snapPoints.indexes, point equals self snap points I. And if we find that this point we're considering is our best so far, we want to store the best distance and our best index. So that if best index is still equal to null, then we can't do it. But otherwise, we know which point it is. Now, I'm going to, you know what? It's not really best index that we need here. I'm sorry, I'm reconsidering. What we really need is the best point. So we can go back to iterating over our snap points. And then we're going to store best point equals pt. All right. So now we'll want to again compute the, well, no, we just want to do, in that case, other.x equals self.x plus best point 0, and other.y equals self.y plus best point 1. Then we want to remove that, that best point from our list of snap points. And listUtils has a handy function to do that. So let's import listUtil, and then we can do self.snapPoints.remove val best point. So remove val removes an item from a list by value rather than by index. So that'll get the snap point out of this one. The other one probably has a snap point that needs to be removed as well. We'll deal with that in a second. Let's see if we can get any snapping at all working, and then we'll refine it. So in end drag, this is where we're going to say, let's see, we need to figure out which piece is best to snap to. So best distance equals null, and best piece equals null for, let's see, sprite and display. Sprites. If sp is equal to drag item, then continue. Don't want to let a piece snap to itself. That would not be helpful. Otherwise, dist equals sp dot get snap dist to drag item. If dist is not equal to null and dist is less than best dist, we should have just put in some big number here. There we go. Then best dist equals dist, and best piece equals sp. Okay, after doing all that, if best piece is not equal to null, so we can just say if best piece, then we want to snap to it. Best piece dot snap drag item. And I think we could probably just say drag item dot snap best piece, and that would also take care of the snap point in the other direction. And then we reset our drag items and drag offsets and all that. Let's see if that works. Okay, so I'm going to try snapping this. Well, first of all, if I drop it nowhere near another piece, then it doesn't snap. That's what we want. If I drop it kind of close to this, hey, it dragged right into place. Cool. So I can very quickly, nope, didn't quite get close enough. Uh-oh. Actually, look what's happened. All of our snap points have disappeared. Why did they disappear? And we have no snapping now. Those debugged lines are kind of helpful. Let's run that again. See if we can determine what causes them to disappear. whole bunch of them disappeared just then when I picked up this piece. And if I snap snap vertically, then the next time I click, all the vertical ones disappear. Isn't that special? Okay, what's going on? Sure, I'm glad I put in that debug display. So end drag happens after the mouse is released when we've been dragging. And then somehow when the mouse goes down again and we begin drag, we'll call continue drag. Oh, you know what? Let's do an update debug display after end drag as well. I bet you this is where it's actually going wrong. So they all have all their handles. I drop here horizontally snapped. And yeah, they all lose their horizontal handles. Why do they do that? Oh, it's because of the thing I said right from the beginning, that when we modified this list, we'd have to be careful to give each piece its own list. I said it, but I didn't do it. So self.snap points equals self.snap points clone. This is a little trick that lets you clone a list. It says copy from the beginning of the list to the end of the list as a new list. And now when we modify that, it won't modify everybody's list at the same time. So I should be able to snap this, and snap that, and snap this to that, and just do this all day, making a nice neat little array of pieces. Cool. And you can see that most of the drag handles are going away. This one didn't. When do the drag handles not go away? That one didn't either. Ah, it's when it snaps to two at once. So to really do this right, we'd have to check to see if there are any other pieces that need to be snapped. In fact, we could just try to snap all pieces to all other pieces. That's an n squared kind of operation, but it's a computer, it's fast. Maybe we should do that. We could make a piece.snap all method. That doesn't even have to be part of piece. We'll just call it snap all for piece A in display for sprites, for piece B also in display for .sprites, for piece A is equal to piece B, then continue. Otherwise, piece A.snap, piece B. My only worry is there might be some pieces in the initial random configuration that that are naturally close enough together that they end up snapping, and we don't want that. Also, if this was going to really be a puzzle game, it just occurred to me we need some way to unsnap a piece from a group of pieces. But that's a detail for another day, I think. Okay, you know what? I don't like this actually. I want to do this on a single piece, and I want to say for other, and then we can say if self is equal to other, continue, and self.snap other. So that'll allow it to snap both ways. The other change I'm going to do is when we're snapping, we're going to automatically snap in the other direction. So we'll just say other.snap self, and that'll only happen if there was a snap point that's available. So this isn't an infinite loop because the first time we snap, we remove that point. And so if we get called to snap again, none of the snap points will match. So that should be safe. But now, in end-drag, we don't really need to find the best piece anymore. We'll just tell it to snap to all. Drag item.snap all. This is simpler. I like simpler. All right, so if I snap these two together, boom, that works. Snap that. That kind of worked, except it's moving the other pieces to the piece that was being dragged instead of the other way around. That's not really what I wanted. I think we're going to say other.snap self. Okay, so I drag this here, leave it a little bit off, and yeah, that's the one that snaps into place. Now here's the real test. If I drag this into the corner, does it snap both ways? Yep, nice and neat. Okay, so there is drag and drop snapping. But now I'd like to be able to grab any of these pieces and drag the whole group at once. How do we do that? Well, I think what we need to do is assign a group number to each piece. And initially, those will all be unique numbers. But whenever we snap two pieces together, we'll ensure that all of the snapped pieces have the same group number. And then when we pick up a piece, we can pick up all the pieces with that same group number. All right, I think that'll work. Takes a little bit of doing, but we've got time. So piece.group equals 0. And then where we're creating the pieces, we're going to assign everyone a unique group number. sp.group equals column times 100 plus row, because these numbers are completely arbitrary. As long as they're unique, we're fine. In fact, I'm going to do it the other way around. Doesn't matter. Okay, they have group numbers. That's the important thing. And let's include that in our debug draw. Right here, we'll do g.print self.group at self.x plus a little bit and self.y plus a little bit as well. Okay. Boy, that green is a poor choice, actually. It's hard to read. Let me try. Dark purple, maybe? Like 880088. Yeah, that's better. That's easier to read. Okay. And now the idea is that when we snap them, we want those group numbers to change so that they're all the same. And that is, let's see. I want a function that changes all of a certain group to all of another group. So we're going to do that. I mean, my code here is not super neat because it's a live coding demo. We'll just stick it here. Renumber group equals function old num, new num. And we're going to just iterate over all the sprites and display for.sprites and say if sp.group is equal to old num, then sp.group is now equal to new num. Simple enough, right? Renumber the group. And so now when we're snapping, what we want to do is take our group number and replace it with the one that we're snapping to. I think it really doesn't matter which way we do it, but renumber group self.group with other.group. Let's try that. So if I drag 305 up against 203, they're now both 305s. If I drag in this one, they both become 5s. Let's get this one out of our way, and so on. Yeah, that works fine. So now we could say when you pick up a piece, pick up all the pieces of the same group number, and we would be dragging a bunch of stuff at once. Now, how do you pick up that many? We don't have support for dragging more than one item right now. So we're going to make this drag items instead. Let's find out where we're using drag item. 7 places. The offset is now going to be the offset of drag items 0. Okay. And a begin drag, I still need drag item. This is a piece actually clicked. All pieces being dragged. All pieces E. So we're going to keep drag item, but we're going to also do globals.drag item equals blank and for sp in display for sprites. If sp.group is equal to, oh, we don't want to use sp again. sp was passed in. For other, if other.group is equal to sp.group, then drag items.push other and for. So now we have the one sprite that was clicked, but we also have a list of all sprites. And continue drag, this is a little bit trickier. What we need to compute is a dx based on the drag item x and the new position that we want that particular item to go. So I'm going to say dx is equal to this new mouse plus the offset minus drag item.x, and dy is equal to the new y position minus drag item.y. Then we can loop over all of our items. For item in drag items, item.x equals item.x plus dx, item.y equals item.y plus dy, so that they're all moving the same way. And then in end drag, we're going to do drag item snap all. Yes, and we'll want to snap all of them. I'm going to come back to that. I choose to ignore that particular wrinkle of snapping when there's multiple items in our drag. Let's just see if we have this much working. So if I drag this up against that one, oh, interesting. It snapped to 2 that were not the same. We'll be able to fix that with our group numbers now. But we have this. That's another issue I'm going to choose to ignore for now. But the group dragging is working. Group snapping, probably not. So if I make one group and then try to like nestle this up to this first group, it's not going to work very well. Although that was a terrible demonstration of it not working very well. Let's try something better. Let's try this. Yeah, you can see this one moved. This one got the right group number, but it didn't snap into position. So we have a little bit more work to do with regard to snapping with groups. So let's think about that. We told this drag item to snap, but we need to update. We really need to tell all of our drag items to snap, actually. I think that might do it. If we just said, for item in drag items, item.snapAll, that would probably do it. Let's try that. Give me a group here. Okay. And now let's drag this close to that one. Oh, it's not going to do it because that one's going to snap and this one's going to be like, nope. again, we need to make sure that they all move the same way. So we can do old post equals item.x and item.y. Tell it to snap. And if item.x is not equal to old post 0 or item.y is not equal to old post 1, then, you know what, there's no reason to use a list here. We'll just do old x equals item.x and old y equals item.y. Then we can say old x, old y. So if the item is moved, then we want to move all the drag items the same way. So for other in drag items, other.x equals other.x plus however it moved, which is, oh, better make sure this isn't item.x. Isn't item again. Okay. Otherwise, how did it move? It moved item.x minus old x plus item.y minus old y. Okay, so we're going to snap the item, then we're going to see, did it move? If it did, we're going to move all the other drag items the same way. Let's try that. We'll snap this to that. And let's see. Let's grab this group and drag it so that it has to snap. Boom, very nice. And you can see our green lines disappeared everywhere they should. That's good. We drag this up against this one. Boop. Yep. Let's make one group snap into another group. Nestle this right up into here. Boom. All working perfectly. Which is good because our hour's almost up. I'm going to take off the debug draw. And I'm going to spend the rest of the hour seeing if I can actually solve this puzzle without having an unsnap function. So I better be very confident in my selections. Okay, so update debug display. We're going to just make this a do nothing by commenting out the guts. We're going to run it. That didn't work. Why? What? Oh, because that's just leftover CRUD from before. Right. We need to at least keep this much where we do the setup. Okay. All right, let's see if we can do this. This looks to me like it goes with, oh, man. Right off the bat, I accidentally snapped it to this piece that I didn't mean to. That's what I meant to do. Do we have time to make an unsnap function? Let's see, what would unsnap do? We'd have to pick up just the piece that was clicked and give it a unique group number. I think we could do that. Let's see. In begin drag, we will check for a modifier key. We'll say if key.pressed left shift or key.pressed right shift, then we want to do something different. Disconnect this piece from any group. So in that case, sp.group equals, I'm just going to make up a stupidly large number. This is not a safe way to do this. What I really should do is like find the highest group number in use and add 1 to that or something, but we're almost out of time. So I'm going to say 1,000 plus floor of 1,000 times R&D. And then that's all we have to do. Else do this stuff where we find the rest of the group and then do the drag offset. I think that should work. So if I drag this to here, we're not drawing the group numbers anymore, so you can't see, but it's got some group number. Now if I shift click this, it's not working at all. Dang it. Yeah, shift click is not actually initiating the drag. Although that did end up getting disconnected, so what am I missing? Oh, it has to still be on drag items. All right, so connect this to that, drag the group, shift click and drag, and I can undo it. All right, sweet. Let's see if we can solve this puzzle then. We have two eyes. Oh, these green ones are going to be tough. Ooh, this ear is not so tough. Boom, there's part of an ear. This looks like part of an ear, a different kind. Okay, got some whiskers here. We got a nose. Can a nose fit like that? Nope. Ooh, here's two of them coming together. That's so adorable. Oh, see, it snapped where I didn't want it to. Let's try this again. Good. All right. Got some whiskers. I don't see where that goes. This looks promising. Oh, that was weird. It's not what I meant to connect to. Why isn't that connecting? Oh. So there's still a bug somewhere. Oh, maybe not. Maybe I just wasn't being precise enough. Okay. Moving on. This looks like this might go down here. Yep. That looks like a good fit. We need an eye here. Yes. This maybe goes here. Whiskers. Progress being made. No. No. Probably like that, but something's missing. Oops, I didn't mean to connect that, so I'll shift click it and drag it away. How about this? Yes. Nice. Notice how that piece connected both groups, although not perfectly. This is a little off, dang it. See if we can repair that. Oh, the problem is once you shift click to remove an item, it's not getting its snap points back, nor is the thing that you disconnected it from. So that's a problem. Boy, that would be a pain to fix. But let's take a few minutes and see if we can fix it. No, I don't want to. I want to solve this puzzle. No, okay, fine. Fix the bug. All right. To better see what's going on, we're going to put our debug display back, and we're going to demonstrate. If I connect this to that, they're connected, and the green snap points are removed. If I shift click, it gets a unique group number, but the green snap points have not come back. So we really need an unsnap. Yeah, piece the unsnap equals function. And if it's, let's see, to restore this one piece's snap points, it would actually suffice to just copy the ones on the piece class itself. So we could do self.snap points equals piece.snap points. But what about the other piece? The pieces that it was snapped to. I think this is where we need to iterate over all the other points. So for other in display for.sprites, if other I can't think of a way to do this that's not super hacky in a short amount of time. Okay, so for point in piece.snap points, x equals other.x plus 0.0, y equals other.y plus 0.1. If our own position is equal to where the snap point would be for this piece. So self.x is equal to x, and self.y is equal to y. Then self dot no other dot snap points dot push point. I think that might do it. And let's call that unsnap method where we begin the drag. sp.unsnap. All right, so if I drag this to here, they're both group 201 and there's no snap points between them. If I shift click, they get their snap points back. Sweet. If it's a bigger group, it should still work fine. Shift click this guy. Now the only weird thing is this is still a group, but I'm okay with that. Maybe this was the only piece that was wrong. You could always just shift click each of these to get and put them in unique groups. All right. So now it's 2:01. Technically, the hour is up. And if you just came to watch me write code, then I guess you're done now. But if you came to watch me solve this puzzle, then now we're just getting serious. All right, here's an ear. This eye goes over there. Remember that from before. Here's part of another ear. Does it match this? No, it doesn't. Oh, but it matches that way. That's cool. Let's make a little space. Oh, and it snapped to these accidentally. We can fix that now, though. Yep, that works. Again, why are you snapping over there? That's kind of odd. Possible there's still some bug there, but... see, I thought that matched, but it doesn't. What else have we got here? We got some whiskers. Do those match? I think they do. Ooh, here's the two noses coming together. I need some, like an eye to go with that. Yep. Okay, this probably goes on top of that. Not quite. Nope. It's got to go somewhere in here, but I don't see it yet, so we'll come back to it. This is not a match. This goes here. Man, puzzles are always hard until you figure them out, and then it seems so obvious. Okay. This is definitely belongs under there. There we go. Oh, they're so cute. Here's part of an ear. Connects to that. But nope, that can't connect to that yet. We need an eye. This probably goes here. So which means there's something that forms a corner in between. Aha. Still no. But this could go there. That looks good. What do we have here? Interior of an ear. Ooh, that's going to be useful. Okay, now we're talking. All right. I mean, it's only a 24-piece puzzle. It shouldn't be that hard, right? But there's a lot of very similar stuff. Hey, there's part of a nose. Okay. Get out of my way, piece. I don't know where you go. Okay, cool. This just general green, does that go there? Yep. All right, so we got some stripy fur. And a little bit of an ear. This looks like it must be his back. Hey, hey. I did it. And it's all one group now. All right, that was fun. Thank you for hanging in there with me, for those who did. And that is dragging and snapping of sprites. Let's see, today we had nobody showing up for the live stream. I don't think this is a great time. it's not been a good time for me either. Weekends are busy with family stuff, right? So I'm going to move this back to during the week. I hope I can find a time where some of you can join me on your lunch hour or maybe right before or after work. For those in Europe, I guess it'll be in the evening. Kind of similar to this time, maybe a little bit earlier. So hopefully that'll work out for some people. Join me on Discord, and you can cast your vote as to what time would work well for you. I'll also transfer this video over to YouTube so that it will stick around and not disappear after 2 weeks. And if there are any topics that you'd like to see, get on Discord and let me know, and I'd be happy to give it a try. So, till next time, happy coding.